Okay. So we have a recording now. Okay. So we'll start with just recap on some point that I kind of skipped intentionally last time because I wanted to focus on what we were talking. When we talk about correlation, what we have in mind all the time, this one like we have positive relationship between the X and the Y. This one less, this one almost no correlation. This is negative, not that hard. This is negative because when one is going up, the other one, the Y is going down. You see when the X is going up, the Y is going down. This is really almost a complete correlation, really like a straight line, a very high correlation, close to one. This is one, that will be minus one. But the bottom one are good examples of be careful. Be very, very careful. If you look at this example, this is like if you do the calculation of how correlation is being calculated, you'll get zero. Although there is a correlation, there is a big correlation. You in this example, for example, you would like to change the coordinate. If you move to a spherical coordinate, you definitely find a correlation. Okay, almost one. You'll get a correlation of one. This one also, you'll get zero, but if you change the symmetry, you'll get a very high correlation. This one a little lower, but this one lower, but be very careful. In all of those examples, you can get a zero correlation. Still, of course, there is a correlation because there is a structure here. If you catch the structure, the correlation would be high. So be careful. We're starting this course by talking about correlation and we're using it. And later on, when we get to the SVM is a beautiful algorithm that take care of example like this one. And you will see by changing the sphere or changing the, the coordinate, you can really get a really nice connections between variables. But that's later to come. Just be careful. Correlation is not always telling you the whole story. In the classical one, it's perfect, but there are many, many cases which they are not the classical one. Okay? I skipped it last time. I didn't want to jump in the middle because we were focusing on what we were doing. Okay. We talked about all of that one. Now we got to this point, and I said, okay, last time, we had our data we downloaded, like what we had here. Okay, this is the data we downloaded. And we have several columns, and we start analyzing them, and we did that stuff. We did when we run the info, we get information about each of them. And sorry, we did correlation. We plotted it, if you recall, to see and get a feeling to each one. We plotted it on, and that's what I recommended anyone that want to learn how to do images like that. You start with an image, and you have all the code open to you. You can look at the code, and you can learn how to make a pictures like that nice, even for Ivory Coast. If somebody will do it for Ivory Coast, it doesn't have to be just house price. It could be any topic, even a district that's selling type of product. You can make a beautiful application of that, a real one, that even useful one. Data exploration, we talked about the data exploration. Then here we said we have to be careful when we're taking samples. If we have a dominant variable that has a high correlation, we saw that this one had almost income had a correlation of almost 68%, explaining 60.68 index of the correlation to explain the housing. So we have to do the sampling accordingly. And we talked that this, we saw the scattered, and then we talked about this one that we should probably remove it. We'll deal with it later on, and that's really diving in more for another variable. Then we looked at prepare the data for machine learning. By the way, we don't see anything here. Really, the everything is really, I put it here. Okay? And when we're preparing, one of the things we do is really just adding new variables, dealing with missing data. By the way, this is something we ran last time, but I didn't emphasize enough. If you look how many, every variable, those are the variables of the data. And you see how many cases you have, like 20,640, but not all of them like that. This one had a missing data. So today I will talk about how to deal with missing data, okay? The other one is, after we did the correlations, we had the correlation somewhere here, and we saw that the correlations, we get all the correlations, but if we take, like if we take one variable, divide by the other one, which could be much more sensible, let's say the number of rooms per household could be a good one. And how do I know if it's a good one? It's just simply when I added, let's say, this variable, I took the total rooms, divide by the number of households, I get a new variable and it has a really even higher correlation than just the total rooms. So maybe this one is even better than this one to use. So we can create other variables and test which one is really a good explanatory. And that's part of the stuff that you do. We will talk also later on, not today, but in fact, it's the next certificate. We'll talk about PCA. You can generate thousands of variables. Then what do? Regression you definitely cannot use unless you shrink and you turn those several variables to a smaller set of variables. But that's advanced topic. We'll get that when there. For now, we can make several of them and we can see which one has the better correlations and then run it. And then we can even check which variable is the best, or we will deal with it maybe today, which one is the best to handle. Okay, so let's see what we're going to do today. Stage number one is we want to identify, we know that this variable has missing data. What we do with the missing data? I have about 270, something like that, missing data. What should I do with it? Should I delete those rows? Should I delete the whole column? Because the other columns, we have all the data. Or should I fill it in? Those are really three options that you really usually have with missing data. Now, depends on the situation, okay? If I have a big sample and there are really few coincidentally, I might delete them and nothing will happen. But I have to be very careful. Maybe the missing data, there is a reason for that of being missing data. If I remove them, I might destroy all my analysis. That might be very painful. Deleting a whole column is really a loss of a lot of information, especially in this case, we have 20,000 and above. I'm not going to delete the column, the whole column, just because I'm missing 200 variables or 270 or 300, something like that. I'm not going to delete the whole columns. That will not be very wise. So most likely in this case, I will fill the data. I try to do what is known as imputation. I'm going to skip this one because I want to spend more time on talking about this box. A very important comment here in the middle, but I will get back to that in a minute. So Python allow me to do really all the options I mentioned. If I want to delete a specific row, so I take the data frame, drop NA, it's missing data. Not available, it's like missing data. So I can delete and then I can tell him anyone that in this row, in this column is missing, just delete it. But that's technical. Please do look at the code. I put it in a minute, I'm gonna show it to you in your program. But the third one is really, and we will see in a minute, I can calculate the median. I can calculate the median for this column, for the one that I do have, and just put it in there. Now, this is what Python person will do, a regular Python person, but a machine learning person will do a little more sophisticated. And after we go over all of that stuff, I will come back to this one. But this is a general rule for machine learning person, how to develop even your own component. That's really a nice way of way of thinking. And here is it is. You can use an imputer. You make there is already in Python the whole library that Skylern it's called. There's a lot of hold a second. Let me make. I wanted to make it bigger. Yeah, let me make it bigger. There is a component. You can use the component already. You just take it from the Skylern. There's a lot of them pre-processing. Okay, you can take this. Why is not big enough? I want it bigger. Yeah, yeah, I want it bigger so you can see it better. Yeah, now you can see it better, I guess. If you look at here, you can already use a component called imputer. In fact, there's many kind. There's a simple imputer even. In fact, for this one, I use simple imputer. Here, I just wrote this one, but you just tell him, how do you want, but pay attention to the way. I'm creating a class. This is like imputer. There's a simple imputer, there's many kind. And I tell him, you know what? I want you to use a median. Okay, I have a one. Next things, here I'm preparing the data. I want to talk about it in a minute, but look at the stages. First one, I create the object. Next one, it's this function called fit. So the imputer, all those estimator, all those components in machine learning have a structure. All of them will have a fit function. And I will talk about it more as we give more example. But please pay attention to the fit. All what the fit does is working on this data set, this housing numeric. By the way, the housing numeric, all what I did here, I just dropped one column. This one, it's the categorical one. It's not applicable for categorical. Secondly, we don't have any missing data there, so I don't have to worry about it. So we drop it first. Then after I create the muter or the component or the algorithm, you can call it, the imputer, I use his function fit. When I use this function fit, is doing it, is learning. This is really learn. Please learn. I tell him learn. And usually the imputer, what he is going to do, because I told him, use the strategy median, is going to take every variable, every column in this data set, and he's going to calculate the median. So by the way, every algorithm will have some kind of statistics or whatever is learning. So here, in fact, the feed is really learning the median. What is the median in every column? Why? Because here I told him, what is it? I just lost it. Hold a second, sorry. Yeah, because I told him here the strategy to be median. You will see if the first time you hear it, it doesn't make clear, but over time you will see I will reuse it with other things as well. And then I will talk about that little box. So, okay, he learned the median, and then I tell him apply it. And the way I tell him apply it, it's transform function. All of them has transform, okay? Say, but pay attention, if you have a good eye, I told him learn on this data set and apply it. Transform is applied. So X is really after he fixed the missing data, is every column that had a missing data is going to fill it up. And many times you will see those components could have even a function called fit transform. So it does this one and this one at the same time. Very, very elegant, very, very elegant. And later on, you will always, you know, you will always kind of, you can do a predict. This one doesn't have any predict because it's only pre-processing algorithm, but we will talk about similar ones in addition to feed, which is learning, and in addition to applying and do something, we will have also usually predict function. And we will have also a score function. All of those will be very familiar to you as we go along, okay? I'm throwing a lot of buzzword to you. It's not really making that clear yet, but I'm gonna go over this example in one more time and showing it to you in the code. And I put a lot of comments there, so that will help you, okay? So if we look at this example, this is a really good example of how you use Imputer to generate the data to be ready for the algorithm, okay? Now, one more things. All those algorithms, and this is really like a rule, whatever they give you out, it is a NumPy array. I repeat, it's a NumPy array. Why is it a NumPy? Because that's the way it does the calculation. It can get a data frame, the housing numbers, by the way, it is really a data frame. You can get a data frame, or I can give you my NumPy as well. It doesn't mean much to you now, but as we go along, you will see how important it is, okay? And you will be expert. You take my word for it. It's just a question of time, okay? And many times, if I do want to play with it more, after I do all of that, it's easy to turn it back from a NumPy to a data frame. Simply you take Panda, PD is for the Panda we're using, data frame, and then I just put the X. In fact, if I didn't put this one, I didn't really have to. You will have a data frame, but you won't have a title. The column will not have a name. So I'm reusing the name that I had originally. So that's why I put columns equal to housing num dot columns. This is a data frame, and it has a property called columns. So I take the same columns and put them back into the NumPy that I'm converting to a data frame. Even if you didn't understand me, I'm going to go over that one more time in the code, and then it will make much more sense, okay? So I clicked here, by the way, when you choose prepare data for machine learning, you get all that corporate. I always love to put it here for you guys, like the professionals do. And in fact, the professional might not document it as much, but since we are student, I documented as much as I could, okay? So let's look at this process, preparing data for machine learning. So let's go back to, you know what, this will be the best many times so I don't get lost. I start all over, okay? And just go back to here, refresh it, and then just choose it again. So the whole code will be generated, it will be easy for me to follow. So we go back to here, okay? And go back to where it started. It's right here. There's a lot of stuff that I put here. Okay, so let's look at it. This is the code and this is the results. By the way, I remind you, you can really, by the page, you can tell what the code here. I always call the name. I always keep lowercase for the page behind, but this is really the title you see on in the drop down. This is in the drop down, whatever you see here, it really is what this is the title. But what really I have behind the screen, I use always this one, no spaces. That's good practice, by the way. Okay, so what does it do? I tell him print it, so I really know that I'm getting my stuff. So this one, by the way, this is printed by me creating, before I get to here, I create the algo. And this is preparing the data, as you recall. Here I did the stratification we talked about last time. And only after those two, I'm starting really looking at my analysis. So the printout here, it's coming from the top two here. So I skipped this one we did last time, so I don't need to worry about those ones, okay? But here is our first one. I'm making a copy of it. It's a good habit when you're analyzing data. Many times you don't really want, this is really our data set for training. Okay, this one was created. We did it last time, if you recall. I get the data, I just make a copy. By the way, in Python, when you use the function copy, this is very tricky. Be very careful. If I delete this one, it looks like you're making a copy, but you really are not. If I make a changes to the housing, it would change my data. I don't want to do that. I want this one, it's the data before I massage it for machine learning. So I always want to keep it the way it is. By doing putting this one back, this is really making a true copy. So if I'm making any changes to the housing, it's not going to touch this one. Be careful. This is very tricky in Python, okay? So I'm making really another copy. So now I have in the memory 2 copies. This one I'm not going to touch, stay there, and I'm going to massage this one, okay? Now the next thing is, and this is really a nice one, by the way, go over that code. If you forget it, don't be angry at yourself. You just means normal person. You know how many times I go over this code, and over time, you will forget, but you will know you did it once, and you go back to your code and you re-see it, and that becomes to be clear again. The first time you do it is really hard. It's really, really hard. So I'm going to go slowly. Please go review the code, and if you forget it, nothing happened. Next time you need to use it, go back here and refresh your memory. I do it all the time. I cannot remember everything that I do. And many times, honestly, at least 60 or 70%, I copy stuff I have done before. But I almost have done almost everything. So it's much easier for me just to go to places and just copy for myself. So let's go and understand this line. This line is a crucial. I'm trying to find all the rows that has missing data. So if this housing has all the data, the 20,640, I want only the rows that has missing data. And I know the column that has missing data is the column that it's the total bedrooms. But I want to do something more general. You know, here it was easy for me. But if I'm getting a big data set, millions of rows, it would be really hard to spot that the total of bedrooms has a missing data. So I would like to use something more general and see what I did. By the way, this one I'm using it, but it doesn't really hurt. It doesn't, by the way, I could use the housing, but I'm not modifying it, so it didn't really make any difference, okay? But I'm taking and I'm checking, here I'm telling him, go to the whole database, look at all the columns. How do I know that I told him all the columns? Because in parentheses, I'm saying axis1. Axis1, it means columns. Axis 0, it means rows. So I'm telling him, go over all the columns, find if there is any null. Null, it means missing data. So go over this huge table, could be even a huge table, find if there are any missing data. Is null, it's missing data. Find if there is any missing data. And you know what I want you? It doesn't matter in any one of the columns. That's why I have any columns. So let's forget about this one for now. And I will come back to that in a second. What I'm getting inside the parentheses is giving me an index kind of, this row has a missing data, this row doesn't have a missing data, okay? I can print it, you will see. And then when I'm using that index inside the housing, anyone that has a true, it will take it. Anyone that has a false, it will not take it. False means it didn't find any missing data in any one of the columns, okay? So, and therefore is picking up only the rows that has missing data. This is a very general, let me put that one so I will come back to this one. I don't want to talk about it now yet. I'll wait in a second. In Python, if I have a data frame, let's say I have any data frame, and I want to pull up some rows, specific rows, I can put in the parentheses and write the condition right here. And it will return only the rows that fulfill the condition. So what I'm doing here, in fact, the housing is my data frame. It is a data frame. In the parentheses, I'm writing the condition. So what the condition that I'm telling him, look in the database and look on every row and see in any row if you have any missing data. It doesn't matter in any column. That's really what it means in a simple Python language. You will get used to that. Honestly, this is a little, but the beautiful part of is null, it's a function of the data frame. This is really a special function that somebody have written. So it's going every row and see if there is any missing data. But I'm telling him by adding any, this is really a function of this function. You can think about it, or a property of this function. And telling him, when you're checking null for every row, don't forget, it doesn't matter if you have any missing data in any one of those columns. Tell me true. If you find it's true, that's the row that I want you to put in this data frame. Okay, so that's the rule for condition. Okay, so now that I got all the rows, I can print all of them. By the way, let me take this one away. Let me take this one away for a second. It will give me all of them. But if I want only some of them, the head will give me about 10 rows. I can write here if I want more than 10, the default is 10. If I write 30, it will give me 30. Okay, so from this data frame, I tell him, just give me only the first 10. I don't really want to look at all the other ones. Okay, fair enough. So this is why I call sample incomplete rows. It's only a sample of them. If you want all of them, just remove this one. Now you get all of them. Okay, let's print it again. Okay, so you can see it. That we'll get a lot of them, not only. Here I just got, you see how many? Only a few of them. Sorry, here, I got only a few of them. I'll get a huge table now, much bigger table. Let's do it again. I will refresh. Okay, reprint it. Done, and you will see a huge table here. You should have a bigger table. You might don't do it because it's too big. Yeah, here we go. Here we go, here we go. Here we go. By the way, when he's printing, you can tell is putting a 3 dots. It means I have a lot lines, so I'm not printing all of them on the screen, but you have a lot of them. So that's really those 3 dots. He's not going to print all of them. The same things. By the way, hold a second. I'm looking for that one. No. Yeah. I thought that I printed on, so this one, didn't I? Let me see. What did I print? No, I did print the sample rows. Hold a second. Sample rows. Let me do this. It would be easy for me to find it. Bear with me a second. Yeah, this is the way I printed it here. But I thought I printed it here too. So bear with me a second. The way that I many times do, this one helped me to find it in the printout. I'm putting a space before and after. So let's restart the server, go back to here, refresh, and I'm running it again, and I should find it there. Okay. Up. Should see those 3 lines. Yeah, what is it? Yeah, here we go. Here we go. In fact, this is really the place that I'm printing everything. But you see those 3 dots telling you have a lot of them. Okay? By the way, you can use a lot of functions. You can do a lot on it. It will print how many you have. But you have it here, by the way. You can tell that this one, it tells you 158 rows has missing data. You see that? It tells you here automatically. So you don't even have to write that function. If I put back here, dot head, and I would put here, let's say 20, it will only give me 20. Let's do it. That's a little function that's good to remember, or at some point you will know all of them by heart. Okay, let's print it again. Let's go back to here. Okay, let's go back. And you will see here, let's find those 3 lines. Here we go. You see now I'm getting 20. 20 will print all of them. And please notice, it's only one variable. I know it's from before because we saw all of them has all the columns. This one is, now it's showing me 20 out of them. And then in the 20, this one, by the way, since I see that I know this is the variable that is missing, if I want to print only this column, I can take from this subsample. I can tell him, please print for me only this column. How do you print only a specific column? This one we already know. I take the data frame and I just put the name of the column. And that's what give me only this column. So if here I printed every column, all the columns, and here I'm putting that specific column. Fair enough? But since this one I'm putting only the column that has missing data, no surprise, I get only an A. And let's confirm that I did the work just fine. So what I would like to do is, I do really want to see all of them. So I'm going to keep this one this way. Okay? And it will print it, it will print all of them, and it won't print all of them. It will just tell me the beginning and the end, and in the middle put 3 dots, means that it's not going to print it on the screen, not to waste time on the printing, but it's good enough for me to see that one. Okay, this one is printing a specific column, okay? Later on, now we're getting, and I'm doing it 2 ways so you can learn from it. I'm doing it 2 ways. By the way, I'm taking that specific column and I'm using a function on a column called median. Now I got the median, okay? I can print it if I want, okay? And after I use the median, this is really interesting. I'm taking all the data, I'm taking this same column, and I'm telling him, please fill it up for me. Everywhere you find an A, meaning a missing, I want you to fill it. Fill it with the median I just calculated. I calculated the median, I put it here, and please fix it. By the way, this is the way someone that didn't study machine learning will do. Somebody has a good knowledge in Python, but it's not a machine learning. I will never do it this way. In a minute, I will show you how I will do it and how machine learning person will do it. But if somebody only studied software engineering, you usually don't have the knowledge that I'm going to cover in a second in here, which is much more elegant. Beyond the elegant, sometimes even longer, but it's consistent. You use it everywhere in machine learning and you get used to it. So even if you forget, you can't really, because you have done so many examples. So this is a simple one that I'm filling up all the missing data with the median. And this is just a little comment. What it does really, it says, when you're filling the data, please update the original one. Usually, if I wrote here, let's say if I did, the default it's false. If I wrote here false, okay, it will do the median, it will put it in, but it will not keep it. Then I would have to write it this way. So this is really just making your life a little nicer. I had to write it this way. It means fill the data, but keep it in here. So overriding this one. But when I'm doing this by itself, if I write a false, it's only doing the calculation and bring it to me, but it's not keeping it. This one doesn't keep it. So in order to just save a little time, because you might do it a lot, and you might see it a lot, people that for machine learning get used to it, and you will see you try to save time and you get used to it. Many of them has in place, you put it as true, which I usually do. Okay? This one is means, fill it up and change this one, fill it up in this one. Fair enough? That's all what it does. Okay, now I have the data, is all complete. If I print that specific column, this column should have the median inside. Okay, you will see. You can look at the median and you will see it's totally filled up. This is the way that non-machine learning will do. How a machine learning will do. By the way, let me just do that. And by the way, we have already a printout of that. So let's look at it. By the way, you can see that after filling missing data, it really is put 433 everywhere in that column. How do I know? Because that's really what the median is. Did I put the median here somewhere? Yeah, the median is 433, but I don't know if I printed it. Did I or not? Okay, let's print it. What the problem, no problem. We'll print the median. Let's go to, here we go. Let me put the median here. I will print the median so you can see it. We'll see it again later on, median. Okay, let me put a couple of those ones so we can identify the median. It will be easy to find it. And later on, I will delete those ones. It's just really for me, easy to follow up. Definitely they have no effect. Okay, I'm refreshing. Prepare data for machine learning. We go into here and let's go back to here. And by the way, you will see now, here we go. You see, the median is 433. And then after you go up here is after I calculated, I told him fill it up with the median. It did. How do I know that it did? Because now the variable has all 433. Before that, that variable has all missing data. So you know that they really did fill it up correctly with the 433. Good. Now, that's, as I said, it's okay, legitimate, but get used to this style. And this is a very, very important in machine learning. See, I'm using a component that somebody have done, and honestly, there's almost a component on anything you can think about it. This is a special component. It's whoever wrote this component have followed rules how to build up component like that. And later on, when we have time, I will even show you whoever is interested in, I'll spend more time in the next semester, okay, how to build up component like that. But let's say this component, I'm using it. By the way, it's defined. I'm not going to go all the way up. It's one of the Skylearn package. So they have a lot of those stuff. And I'm telling him the strategy I want you to do, simple, I'm building up, I'm building up an object. It's not doing anything yet, nothing. I'm only building an object and I'm telling him the strategy I want you to use median. By the way, I could have told him use the maximum, use the minimum, use the mean. Okay, you can use anything, but here I'm asking him to use the median. Okay, stage number one, I created an object. Okay, now the next thing is I'm going to use it. So really the truth of the matter, to be elegant, to be really, especially for students, first time, this one, let me take this row out here and put it before. I will do it before, it doesn't make a difference. Just to focus on my point, let me put it here. It won't make any difference. First of all, what I'm doing here, I'm taking the data frame. The data frame have a lot of several columns, and I'm just telling him, please drop. Any data frame has a function called drop. Drop is meaning you can drop or a row or a column. So I'm telling him, please drop the ocean proximity. And this is in a column. That's why I put axis1. So in this housing, please drop for me the column ocean. And if you're looking for it, it is in the columns. So this one is going to drop the column ocean, the ocean proximity. And I have a new database, a new data frame, I should really say. Okay, and I'm going to work on this data frame. Now, I want to focus on this component. I'm creating the component. Next stage is I'm feeding. It's like learning. Feed means learn. Study the data. Hey, hold it a second. What do you mean study? What do you want me to do? And I already told you. I can tell him. I already told you. I wanted to use the strategy of mean. The meaning, when you study the fit, calculate for every column here, just calculate there the mean. You know, if you really want to make sure that the studying is correct, you can print it. You can take this one and print it. This one will give you the mean for every column. In fact, I just printed it up for you here. The missing data, not missing. You see the 433 here? It calculated the mean for median for each one of them. That's what this line does. This is what this line does. You always can get the result. Every component will have its own variable to get the result. It might be different name, but it always will end up with an underscore. It's a convention of those components, okay? Which makes your life easier as you go along. You know, all components behave the same. It's really nice. In the beginning, it looks like, wow, it was much easier the way I did it before. But as you get used to it, you see all those components so systematic, so you never really forget and you don't have to think about it, okay? By the way, the only reason by the way, this one also calculating the medians, but the reason I calculate so you can see they are really the same. Whatever I calculated with this component gave me the same if I did it like in the primitive or the software engineering style. I can calculate the median, and then when I put views, it will just print it. So if you look at here, I'm putting it twice. The first one using the component, the second one, it's like the primitive way. And both of them, of course, will give me the same result. But I like this one. It looks longer, but over time, you will see that this is the right way to do things because it's consistent. And by the way, remember I skipped this part because I didn't want just to say it and then you start looking for, okay? Here is consistency. And that's the reason why it's so beautiful. You will see the consistency is really meaning that all those components are built very similar. We're using the first one, but we'll use others as well, you will see. All of them will have a function called fit, the one that we just used, okay? When I created, I told him, please use strategy median, okay? By the way, the median has even a name that it's called hyperparameters. It's hyperparameters because that's affecting how to study, how to learn, okay? So hyperparameters, we will see it a lot, okay? So after we created the objects, we're defining in the creations of the objects, the hyperparameters, we always use the function fit. In this example is calculating the median for every column. Then we always use transform. Remember, we use that one. So the transform is applying, okay, how to calculate the median. Okay, after I get the median, in this one, we don't really need it. By the way, we can use even fit transform immediately. In this example, we can use it because after I study it, I apply it. Applying it's really transforms. Okay, I applied. So I could even have used immediately just one time fit and transform as we will see in other example. And it means I'll explain this one more time. Some other component, this one doesn't have any predictions, the one that we used, it's usually you will have also predictor. And we will see that example in a minute. Another examples you will have, and you will see score. When I predict and I get prediction, I would like to see how confident I am in my predictions. We'll have a score. And the beauty here, you will get used to all of that, you will see, because they are repeating same structure, beautiful way of doing such a sophisticated stuff in an elegant way. So I won't get in fact, I will skip this one because it won't make much to you, but I will get back to that in some point. And in fact, even in the review, I might go into here, it will make more sense. For now, all what I wanted to say is start being a machine learning person. This is the style we would like to use. We define a variable, we use a fit, and then we use the transform, okay? We use a transform. I did a feed, I studied, I didn't really use it yet, but the next one will be a transform. Here as we go. Impute, transform, and that will give me the X. The X will have already all the data filled. Doesn't matter which column, it will put the median in. And here I'm just really printing it, I think. I'm just printing it. By the way, one more time, all those components returning a numpy. So if I really wanted to be back to a panda, I had to use this one, panda. And then again, I'm using the columns because numpy don't really hold, does not hold the columns the same way that I'm expecting it in in Panda. The beginning, it's so confusing. We will get used to it. You will take my word for it, okay? And finally, by the way, I'm also using an index. I will talk about the index in some other time. I think I gave maybe one example, but we'll talk about it more in the future when we get to time series. Okay, after I got it back to be a data frame, I just printing the head. That's one you already know what the head means. Print just few lines, and that's about it. By the way, this one, it really is a good one to start getting used to. How do I read a lock? This is really, by the way, this one I can use only with the index, okay? Maybe this is the time to explain what this index means. Every data frame have columns. If I don't define the index, it will give like kind of, you can think about it like a primary key of the table. You can think about it that way. It will give numbers from 0 to up to the last one, 0, 1, 2, 3, 4, 5. And that's the default. But if I don't want it to be the default, I can even assign a specific column to be the default, okay? To be the index. We have used it, in fact, in chapter 1. When we do a review, I will remind you that again. We turn if you remember, we turn the country to be the index, and then we combine two tables. It was too hard to explain it at that moment. Now that we're thinking about what index means, if this table might have an index is like the primary key. I can use a specific column and turn it to an index, okay? Or if I don't do it, it's like here, I didn't really do it. So I will have 0, 1, 2, 3, 4, 5, whatever it is. That will be my index, okay? If I want to put up data, okay, I have, by the way, this is a really interesting one to follow. And please pay attention to the way it's really written. I take the sample, all the data that I have, this is exactly the incomplete. Remember the incomplete? Everybody remember? This is the one that are missing. This is the one that are missing. So I'm saying to this, please give me the index, the values of the index. Okay, I got the values of the index. What does it do? By the way, the function log, we will see it in the future a lot. I have a data frame here. This one already have all the data in it, okay? After I fill up the missing. Now I just want to see those rows again after I fill it up, like what we did before. Just this time, a different way, slightly different way. I'm telling him, give me all the rows in which the columns with this index. That's really what, I can delete this one, by the way. This is just really, this one I will see all the rows. If I want to tell him, print for me all the rows, I'm telling him, okay, please, these data sets we created before. Remember, this one is the one that has missing data. That's the one we did it here. No, this one we filled. Where is that? We defined that. We defined it here. Okay? We define it here. We print it up. This is the rows that have missing data. You see, there is null, it has missing data. Now what I'm asking him to do, I want to get them big. So I'm telling him, take those rows that I find before, take their index, give me the value of their index. If I take the value of the index from this big table, this is like 20,000 and something, give me only luck, it really location. It really is not luck, it's really location, a short for location. Give me only the rows with this index. In another word, give me those rows again. You can think about it. Now, when I added this one here, don't give me all the row. This one will give me all the row. But I'm telling you, you know what, I'm not interested in all the rows. I already know the other one don't have any missing data. Just give me this column. So it's giving me only this column. So in another word, when I'm printing here, I'm getting only the columns. We can see that here, you see I'm getting only the columns. You see, this command is giving me only the columns of the missing data. By the way, one thing is interesting, it will give me, that index is really just a simple numbers because I didn't put index really, just simple numbers. So when it's printing, it's just putting the zero. This is really the places, by the way, you can see which row I had the missing data. If you really, that's really what helps you for now. Okay, so one last things, okay, by the way, what does it print here? If I tell him impute strategy, you can guess what it would give me. If I forgot how I did it, you know, it has internally, is keeping the value I gave him originally. You remember when I created this impute component, I told him strategy mean, median, it will keep it, it will remember. The impute will remember it. So this one will just say median. Okay, if we go down, yeah, no surprise. You give me the name of the strategy I use. This is just the truth of the matter in normal life. You will never really print this one. It's stupid, yeah. I just wanted to emphasize that it keeps a lot of information inside. So this is a class. This is an instance of a class. It's a very important component that holds a lot of information. Okay, let's continue now. This one I will hold a second. I just want to go over the whole things one more time. Okay, what we did today so far. We looked at the data. We looked at all the data. This one we know is created from last time, last session. We created all the data. We took a sample. We broke it up to training and test. And now I'm looking only at the training data set. I'm looking at the training data set and I made a copy. So this is all the training. We have there 60,000 rows, I think, if I remember. No, I'm confusing with the other one. We have about 80% of the 20,600. Okay, 80% of them. That's about 16,000. Something like that, 16 or something like that. About 16,000. Okay, those rows, I'm checking only the rows that has missing data. So all of those, how do I find missing data? Simply we know that these data sets, this data frame has a function called isNull, and it's checking in all the columns if there's any missing data. If it has a missing data, it will say true. And this data, the housing, which I just made a copy of, is going to pull up only the one that has missing data because only the rows that has true here will pull out. So beautiful. Stage number one, let's find all the rows that has missing data. Next stage, I'm going to skip the software engineering style. I'm going to jump to the machine learning style, the way I like it. The way to fill up those rows is as follows. We first of all create an, what did I create? Where is it? Here we go. First of all, I create an object and I tell him, I want you to use a strategy to be the median because I want the median of that column to be used in the rows that has missing data. So stage number one, I'm building the component. Luckily, Skylearn has, many people say Scikit-learn, many people say Skylearn, whatever you feel comfortable. It's really a way of just saying the same library. It has already a component. All what I have to do is use it. And I'm telling you the strategy will be use the medium. Okay, I have a component. First one, I apply these objects on the data, the housing num. It's all the columns in the data set that has numbers. Okay, is learning. This is the learning stage. Okay, fit is learning. Learning in this case is really calculating the median on every column. If I want to see it, I'm just gonna print it, because in this case, it's putting it in a variable called statics underscore. It's a very common to use a name with an underscore. Other component might have different name, but you always will use it with underscore. It's convention in machine learning. Okay, next one. After I use that one, by the way, this is just one I wanted to show you. By the way, this is the software engineering style. This one, see how nice. Build it, fit, got the result. Next one will be transform. Transform means, okay, put or fill in the missing data. The transform is putting it here. By the way, a short way, I could have avoided that. I didn't really have to do this one. Okay, I could have done it very simply right in here. By the way, with one command, I could have used field transform. You see, field transform. That will do the job. And I could have, okay, like X here, and that's it. So it becomes to be really much even more elegant. See, I'm building the component. I tell him study and apply. This is it. X has no missing data. Beautiful. Okay. This is really the bottom line what happened in the end of the day. That's really, all the rest is really like, I put it there for you because you are a student, so you can really learn more things that are inside. But real life, that's what you will do. You build up the component, you give it the strategy, and fit and apply. Transform is really apply. X has no missing data. Okay, I will just put it back. So you will have the way as a student. And in the future, remember, we will use fit transform. Most of the time, really depends. Usually what will happen in data preparation, you will use fit and transform. When you do predictions, you usually don't do that. And I will talk about it when we get there. But this is a nice convention to start getting used to. Remind you, X is a NumPy array. Turn it back to Panda. It's really just using Panda convention. This one I'm putting back. By the way, if you notice, I had columns here before, and this one I didn't touch. This data frame I didn't touch. So I can use this column to recreate the housing after the transformation, meaning after I fill up all the missing data. Okay, I took the X, I used the same columns, and this one I just told him, oh, you know what? Fill up the index now. Okay, now it's the time to tell you. Okay, take the same indexes I had before. The truth of the matter, this is a useless. In real think, this is useless. Why is it useless? Because I never really defined the index for this data set. So there's going to be numbers. So even if I didn't put anything, nothing will happen. It will use 0 to whatever it is. Putting it back, it just really says use those ones instead. But in real life, it will not have any difference because I didn't really define any index for this one. When you do studies more complicated one, you will change the index, and then you would like to keep it to be for this one as well. Okay, the rest is really simple stuff. How to print the head of this transform. This one is just, again, to remind you, please, this line, please, this is very important line. I went over that, go over that again at home because we will use it. This one, I'm pulling data from this huge data set, like 16,000. But I want only the columns that I have put I put the median inside them. So we will use in data frame a lot the location and the location asking for the index. So I'm going to the sample incomplete rows. There's the one that had missing. I take the index values and pull from these data sets only the columns that had missing before. And after I get all those rows, I said, I'm not interested in all the rows. I'm interested only in the column. That's why we put the column here. So please do go over this line again and again and again, several times. And we will be using it a lot, okay? You will see in machine learning, it's a very common line that's very important to understand. Okay, so that's what we did so far today. We have one more and then we break. Remember, we dropped that column ocean proximity. Usually ocean proximity, remember, we have several categories. We even pointed them out, you know, nearby and all of those ones. In machine learning, we're not going to use them that way. That will be a very, very, very incorrect. Moreover, we might even turn them to numbers. We did, in fact. If you remember, we converted the ocean proximity to be, instead of the name, we convert them to 1 up to 5. We had 5 categories. You can say, wow, this is beautiful. But this will be a very wrong things to do in machine learning. Anyone can guess why. It's not a good idea in categories. So what are the categories we had? Let me see if I can find them. I think I might have them still here. You know, we printed them last time. Now, you know what? I will go here. You know, I'll get back to that one again. Just because I remember in the get data we did them. Okay? Remember we had those categories, 1, 2, 3, 4, 5 categories. And we said using word is not good. We want to convert them to numbers because everything we want to convert to numbers. But see what would be a problem using a variable? See, we have about 20,000 numbers in that column. 5, 4, 3, depends how far you are from the ocean, okay? Or if you are island, and you got 1 to 5, okay, those numbers. But now I have a long variables has numbers. What's the problem if you're using, anybody that studies some statistics probably will recognize this problem. By the way, if I have numbers from 1 to 5, a variable have 9 for 5, and I tell you, here is the column. Let's say this is the only things you have, okay? You have only one column. You have 1 to 5. What mistake you might make? I tell you, tell me something about it. I'm really not giving you much, but I'm telling you, what do you think? If this will be a good idea to use that one, is it a bad idea? Anybody has an idea. I mean, this is a little subtle point, but try to think about it. What do you think? What's the problem? Can everybody hear me, by the way? That's what I gave you guys. I gave you a column, only one column. Forget about the whole exercise we're doing now. 20,000 numbers and a lot of rows. 20 rows, only one column. Numbers from 1 to 5. Which mistakes? And I tell you, tell me something about it. Which mistakes you might do? Hey, here we go. I will help you out. Okay. You have 20,000 numbers in a row, a long column,
Yeah.
In the middle, you know, I see a lot of 5, 5, 5, and there is a missing number. And then under that, okay, we'll have 4, okay? Under that
Okay.
would be 4, 4, 4, 4, 4. Which mistake you might, I tell you, fill up the missing data. You can take the median, correct?
Yeah.
The median will be 2.5. There's no such a thing. Am I right? Am I right? The median 1 to 5, it would be 3. Sorry. 1 to 5, the median will be 3. Okay, between 1 to 5. Will you put a 5? You can put a 3. Is that right? Am I right? If I use median, I had a missing data. And other things you will say, well, above the missing data, they were all 5. If
Yes.
everything is below it, also 5, I would say it should be really 5. Okay? Or if I see all above that, it's 5. Below that, it's 4. I might say it should be 4 or 5. But that might be wrong. Because I'm taking a number close to 5 or close to 4. But I don't really know the meaning of 4, and I don't know the meaning of 5.
Yes.
4, 5, 1 has no meaning.
Yeah.
Unless I go to the table when I convert it, how far is to the ocean. Is that right? And that's a classical mistake you might do. So what we do in order to isolate that we think that 5 and 4, they are close friends, but the children no matter 5 and 4 might be far away. Depends which category it is. Okay? And 5 is not closer to 4 than 5 to 1. They have no connections. It's category. Okay? I said men and women. Okay? Women is one category, men is one category. Correct? But let's say I took men, women, children. I have 3 categories now.
Mistake.
The men I put 0. The children I put 1. And the woman is 2. The truth of the matter, 0 and 2 is closer. Man to woman is the same category as a family, maybe. I don't know, or whatever, as a couple. And children maybe something else. But let's say I have this. The man of the house, the woman of the house, children, and a dog, an animal of the house. Okay, I have 0, 1, 2, and 3.
Yeah.
2 and 3 are not close to each other. The children and the animal is not close. And in fact, the animal is not close to anyone, depending how I want to look at it. So the numbers, by the fact that I named it 0, 1, 2, 3, don't learn from it. I don't want the algorithm to learn from it. So I want to destroy that connections. That's one, it's really a genius, whoever came up with that idea. That's why we have 5 numbers, 1, 2, 3, 4, 5. I'm turning it into what is called one hot vector. What I mean by that? So I can take a vector of 5 places. So far, so good. 5 places. And I tell you, you know what? If it's a number 1, if there's a number 1 in the vector of 5 zeros, change the first location to 1. If it's a number 2, change the 0 in the second location. Keep all the rest zeros. If it's number 5, keep the first 4 zeros, the last one, make it 1. Now you see, I have now turned the whole huge column to 5 columns, but I have only ones inside. 5 columns, but have only ones inside. So there is nothing, no connections between them. It's true, I did convert them to a 5 columns. Whoever study regressions is like taking categorical variables and turning it to dummy variables. Whoever learned that, okay? In regressions, you take categorical and you convert it to a 5 columns. In our examples, it will be one every, for the one, we'll have a new variable, we'll have one every place that it was one, it will be one, and the other one will be 0. For 2, you have a new variable, and 1 only the places that has 2, and 0 in the other ones. Very similar to the one, when you run in SPSS, by the way, a regression with categorical variables, it does it behind the screen for you.
Linear
Okay?
regression.
But if you really study your statistics in the right way, that's what it does. Okay? Here we do it explicitly. And in fact, the beautiful is that the beautiful part is that machine learning tools or all the stuff that we have, really we have a good friend that does the whole work. Here I elaborated a little bit. I did it some stage by stage, okay? But in fact, no, in the book, in the text. But here, really, this is the way you will do it. So simple. You pay attention. Very similar to the way we used the previous algorithm. There is another algorithm called one-hot encoder. I'm building an object. This is like creating the objects. What the next things we do? Feed and transform. Here I used it immediately. I took that column, house categories. In fact, this is really what I did here. I took only that column. I took this algorithm category encoder, I call it, but this is really my objects. We have it in the Sky Learning library. And after I created it, I just take that one, I feed it and transform. So I did, that's what I told you, that's what we will do all the time. So this one, if I ask you in the exam, how many columns do I have here? The answer is supposed to be, I have as many as the numbers in this category. If I have only 5 numbers, this one will have 5 columns. If this has 10 type of numbers, it will give me 10 columns, okay? And this is really what I'm going to use in the learning later on. This one I just printed out everything. And next week, okay, we'll continue. But what we have done, it's really not a trivial. Later on, it will be very trivial, by the way. For now, it's first time you're hearing it, the first time you're using it. And how do we take a data, prepare it to be used in a machine learning algorithm, okay? And we talked about 2 types of data. One, which is numbers, like all those columns. And that was missing data. We filled up the missing data. Then we said, okay, after you fill the missing data, this column last session, we convert them to numbers from 1 to 5. And today we learned that that's not good for machine learning. We convert them to 0 to 1. By the way, if you go down here, I printed up for you, that column of 1 to 5, it really is turning. You see, this one, by the way, it's a number. This is conversion of number 1 because I have the 1 only on this one. This is also 1. Who can tell me which one is this one? Which number is this one? This is conversion of which number? So I have 0, 0, 0, 0, and 1 in the last one. So which number is it? Remember we said we take a vector.
5.
Which one? 5, correct. Which number is this one? You have a 0, 1, 0, 0, 0.
2.
2, exactly. Because we have 1 in the second location. That will be a number 4. Because we put the 1 in the 4th location. This one, the way we use it, even in regression, when using regression, whoever studies some statistics in school, and you run a regression. That's what it does to categorical variables. It does it automatically. Here we like to do it, and you will see when we get to when we get later on next certificate, we get to dive into inside, and we talk about neural network a little bit. You will see neural network is almost a must understanding this conversion. I might have 10 categories. And in fact, next chapter, we're going to use that. We will use a specific, we'll use a stochastic descendant algorithm, but later on, we will see that we will need 10 categories and we want to predict the 10 categories. You will see we will use the same mechanism, okay, defining the variables that we want to predict. And we will see it next time. So this is a very important concept, a one-hot conversion. That's really what we do. We have a nice algorithm now, and you will see there's other algorithm embedding inside it, already does it automatically for you without even, so, but step by step, okay? Hope I was clear. Any questions, guys? Today we dealt with data conversions mostly.
Okay, I have questions.
Sure.
So regarding the preparation of the data, is it possible to deal with all the data set? Now we are here, I think we use, for the missing data, we use the training set. But if you have a data set and then you want to find the missing data, you can do it without splitting the data.
Correct. In fact, if you saw, when I was looking for the missing data, and that's why that component is beautiful. And the component, by the way, before that even, when I try to see here, this is all your data. By the way, this one is a copy of this one. In fact, I could have used this one, it would be the same. Okay, maybe less confusing. Because I made a copy already, is that right?
Understand.
Yeah, it's the same things. Okay. Okay. I'm taking the whole data set and I'm telling him, find missing data. Sorry. Sorry about it. Thank you. Thank you. You see it now, yeah?
Yeah.
Okay. Sorry about it. I'm saying Control Z. The other thing is, this is, by the way, it's the same. If you remember, I made a copy of this. So this one is the same things. I'm working on the same data set. So let me put that data set so it's easier for the eye. Okay? What I'm telling him, as you said, Raman, go over the whole data set. This really is the huge table. Find missing data, and I don't care on which column is the missing. Bring me all the rows that has any missing data in any column. All the rows, again, in this data set, find missing data, doesn't matter which column it is. So this is what finding all. So in fact, if I take only this one, maybe it's worth to do it, okay? Let me take this one and print it. Let's say, who wants to guess? What do I get now if I print this one? I would get a long column, false, true, false, true. Most of that will be, okay, will be false because most of the rows have data. Let's print it, okay? Hopefully one of them will be missing, okay? Otherwise we'll see all false and we maybe will be lucky and we find. Let's print it. Okay, and maybe we'll find a huge one, so it will not print it is the way I would expect it. Yeah, we got here. No. Here we go. You see that? I was right. We see all false because is only showing me a little bit, okay? But there must be like, I don't remember how many were missing there, 100 or 200 or 300. There was some missing. Let's try more than that. By the way, but the key point is I got a huge column. Everywhere that it says false, he's not gonna pick it up. He's gonna give me only the places that has true. Let me try here. By the way, this one you should know by now, okay? This is a column, is that right? Let's do that head. I'm not sure if it's returning this as a data frame. I hope so. And I'm gonna make a 500. So it will print 500, okay? So maybe one of them will be true or we'll find one. But it will, everywhere that it has a true, it will should show it. But it's good be, we'll be lucky if we find one of them. Let's see. No, I couldn't really cheat it. I tried to cheat him, but he printed the head, but he chopped it off. Or so I told him, he saw it's too big a number, so he didn't print it the same way. So sometimes if I put maybe 40, it might take it. Let's say 20. Maybe it will take 20. Printing takes a long time in machine learning. He will not print. He's trying to save his engine to, let's see if I can get 20 now. Yeah, here I have more, but they are still all false. It's also price. Out of 20,000, I have 100 or 200. Most of them are false. But this is basically giving me a column. Everywhere it has a true, there is a missing data in one of the columns. That's why we put the any here. Okay, and that's really what you wanted to do. Is that right, Raman? So now we understand really what the meaning of this one. This one, it's any column that has a missing data, say they're true. And if this is true, it will return that all, and that will be part of this data set. Okay, more questions, guys? Questions?
What about duplicated data?
Duplicated? That's an excellent question. Once I almost killed somebody because he tried to cheat me and he put a lot of duplications. So the data will give me the result he wanted. And I ran an outlier algorithm at the time, and he find all the duplicated. I don't think in chapter 2 or 3 I dealt with that, but definitely later on we will deal with it next certificate. That's a very important topic. Duplications, outliers, it's really part of outliers, okay? And sometimes duplications is okay, but if I have half of the population duplicated, that's probably something is wrong, unless depends on the problem. But normally you shouldn't really, especially if even two people twin, most likely one of the attributes will not be the same, you know? So if I'm getting a duplicate, it really is a problem. By the way, there's a lot of sophisticated, I can even tell you how it's done behind the screen. There's some algorithm called hashing. And it's being used a lot in databases when you want to find duplicated rows, okay? So you take the whole rows, you apply some algorithm on it, and it will give you a unique number representing whatever it's written in one of the columns. Now, if you're getting the same hash, that means those two rows are the same. They are duplicate. So there's a lot of those type of algorithm. Hashing is one of them, okay? But it's very important to check for duplication. The duplication is maybe somebody, it could happen, I get a secretary and I ask her, put the data. I gave her 20 Excel. And by mistake, one of the Excel she put twice, okay?
Okay.
And you want to make sure that those errors didn't happen, otherwise you get garbage, correct? So this is a beautiful question, by the way. More questions, guys? By the way, Draman, honestly, I wish I had one of my students now was to employ him to do my PhD. It could have saved me a long time. You know, if somebody had that knowledge and he can work for somebody doing his PhD or even a professor should hire our students, you know, because they should really not spending their time in programming. They are not a programmers. They don't have time to be a programmer. But the data, and honestly, don't quote me on that. He should be paid more than the professor because he knows more than him. You know, the professor is focusing on a very specific one. So as long as I hire the professor for his specific knowledge, he should worth a lot of money. But if dealing with the heavy things, that data scientist is more valuable, 90%. He can shrink, you know, if a professor needs to do his project, take him a whole year, I put a data scientist next to him, he can do it in a month. Am I right? The professor should only read and write. That's it. Read and write.
Read and write.
That's it. Everything says is a data scientist. Everything is data scientist. And 80% of the work is the data scientist work. So anyway, so those students could be really valuable everywhere. You know, no surprise, data scientist is the hottest prestige job today. It really is, and no coincidence, you know, this is a very valuable knowledge. That's what I told you, you didn't believe me. When I testify in court, you don't want to know how much I charge. You know, it could be for hour I charge almost the salary of a year of a person. Because not everybody can do it. And you know how much knowledge you need. And it's enough one mistake, the whole results will be totally different. You know, once I was asked in court, I tested, I think I maybe mentioned it in that case study. I was talking about the computer vision, you know, the quality of computer vision. The guy asked me, you know, we have 24 employees, scientists, working on this job for over 3 years, and you spend only 10 days, and you're telling me you're giving me better results than they do? How would you answer a question like that? I told him, you know, I spent 10 days on analyzing, but I used more than 40 years of studying. And the judge liked my answer. You know, sometimes in 10 days, you can do more than 24 people doing for over 3 or 4 years. And this is a phrase that I'm going to put in Academy City. It's very true. One excellent employee worth more than 100 very good ones. I'm not telling you good ones. One excellent employee is much better than 100 very good ones. You know, everybody wish to have a very good one employee. But if you are an excellent, you can do better than 100. So that person should be paid more than 100 people. And honestly, I'm teaching my courses in a level of MIT, Harvard, Chicago, Stanford, and I'm not going to go down. Because you will see, and everybody, I'm recording it, okay? One day we'll get donations from our students. You know why we get donation? Because they will say, thank you for teaching me that stuff. You know, I'm donating every year money to University of Chicago because I studied there. What they gave me, no other university could give me. They are very special people there. And I'm proud to donate. I think And I would like them to take that money and give to the next generation students. I got a stipend when I studied there. You know how much it cost a year in Chicago? More than $100,000 a year. So you get your PhD, it's about $400,000 to $500,000. Now, who can pay those amounts when you are so poor? Nobody, unless you get a stipend. So the beauty here, you give good students the stipend. They become so good, they make a lot of money, and they will pay it back. No big deal. And that's why University of Chicago is a very rich university. Very rich university, is extremely rich. And don't think it's not because of the tuition. They're not making a lot of money from the tuition. They're making a lot of money because students donate. Second, they develop a lot of patents, the professors, and the patents worth a hell of a lot of money. Usually it works like 80% the university keep, 20% goes to the professor. The only things you keep, if you get a Nobel Prize, you keep the whole amount. And by the way, the economics department in Chicago, I think almost all of them, unless only the young one don't, but everyone above 60 have a Nobel Prize there. You know, my PhD, I have 3 Nobel Prize signed my PhD. You know, that's what I believe. And I think life becomes to be, honestly, I would be so happy to find in Africa now. You know, I'm not going to be, you know, I'm very idealistic in many topics, but you know, the last half a year, I went back to a topic that I'm so interested in. I learned a lot about slavery, exploitation, and honestly, it's everywhere in the world.
Yeah.
In Africa, it's the most visible one, you know? You know, why the Portuguese came to Ivory Coast? Why Ivory Coast is called Ivory Coast? Because of the ivory. But why did they come there? And you know, it's a fraction of it. They wanted to take the ivory and they didn't care killing people. And now I want to say the other way around. You know what? God have making justice now. Now God have made the internet. Now God can allow me with this small box that I want to bring as many as I can to Africa. And everyone can sit in his home with the internet, study in a level of MIT, Chicago, Stanford.
Yes.
And they are as good as the European and pass them. And you know why? And Africa has a better chance to get to a higher level than someone in Europe. There's an expression in the Bible, in the Jewish Bible. It says, be careful with poor people, because only those will be able to study the Bible very good. Only poor person can study very good. Amazing statement. You will never think about it. You know why a poor? Because he's starving. He's in front of a lion. He has to be good. And he studied from his heart. Only someone that studied from his heart can be very good. Otherwise, you cannot be good. It's too hard. So Europeans are too spoiled. They're not going to study as hard. Europe is over. Take my word for it. Europe is over. It's over. It's done.
Okay.
And the truth of the matter, Europe has their wealth. They stole their wealth. They didn't create it. And I know a lot of history. Believe me. I know too much history because it's so important. And this is the time to, you know, show the world that Africans are not less good than anyone else. By the way, I'm an African, if you didn't know. I came from Libya. So I myself, they came and they stole all the North Africa, Morocco. They came all over the places. So I want to prove as an African, I'm not less good than anyone else in the world. That's why when I started, by the way, I'm one of 10 children's family. I had no money. I used to go with, I didn't have money. I had money to buy or a book or shoes. What will you buy? I bought books. Honest to God, it's a true story. But I'm proud African. And we can get to a much higher level, much higher level. And I see it already, by the way. I teach you guys and the guys in Uganda in a much higher level than I can teach in Israel. I cannot teach that level in Israel. It's not coincidence. So anyway, I think this is a good way to close the session today. Please, I'm uploading all the stuff to the YouTube. Please watch the videos, go over it. Don't give up, never give up. And eventually everything will get easier. Have a good weekend. Okay?
Okay.
And Sergey, I would like to talk to you about this accounting.
Okay.
Think about it. I don't know what your terms you decided that you're going to teach later on. It will be beautiful project.
Okay.
Well, first of all, we'll have an accounting package. We'll use it for teaching, and we'll develop accounting management ERP eventually, but step by step, with a long vision. If we get there in 2 years to be the perfect, or 3 years, beautiful. But we can, in 3-4 months, we can get a very nice accounting rolling.
Okay.
And I will put it in Academy City, and then we can even have, it will be really nice, even businesses starting using it. We even can give it to minimum, like donation. Everyone will donate something. So we can hold some students, give them a little salary so they can maintain it. And that will roll over as we go along. So, okay. And if you have time tomorrow, I'm free tomorrow after 11,
Tomorrow, okay.
my time.
Eh,
After 9 o'clock your time, I will be free. If you
After
want to
9,
talk
okay.
about it, I will be more than happy. Anybody of you guys, Toko and everyone else, okay? Have a nice weekend.
Okay.
Okay. Thank you.